Hi there, this is Jacob Nash, and I'm going to be talking about the different formulas that you need to know for ACT. So you might have wondered this because, unfortunately, there are some things you need to memorize. Really, the math test is the only one that's like this. The other tests, English, reading, and science, well, you kind of have to know a few things for science and maybe some grammar rules for English, but really you don't need to know that much for those. But let's first talk about sequences. That's the first thing we're going to talk about. So number one, there are different kinds of sequences. And if you know, a sequence is just like a series of numbers, and using this you can tell what would come next. So here's what the arithmetic one is. And of course there's different ways to write every formula, but anyways, the arithmetic sequence, basically the numbers they have kind of like a common difference. So you would need to know that that's the first term. So if you had something like this, then A1 is 1. And C would be like 2, because if you notice 2 is added each time. And let's say you wanted to find the number 44, the 44th term, then you would solve that out and that would tell you what it is. So that's what arithmetic sequence is. That's what you need to know. But there's another kind too, which is geometric. So the geometric sequence, instead, this one's more like things change sort of by like multiplication and division instead. So here's what this one is. Oops. It's like this. Right. Yeah. So same thing, but this time you have it multiplied. So that's the only difference. So that's the sequences. Now we're going to talk about logarithms. That's number 2. Logarithms. And it doesn't matter if you don't know what this is. You just need to remember this. This is the same thing as this. So what does that mean? Well, let's say you had something like this. 7 to the what power equals 152. Well, you might not know how you could solve that. I mean, usually you would think if the thing that you were trying to find was this, then you could just take the square root or whatever root you would need to take. But this time, you just have to rearrange this. So 7 is A, X is B, or sorry, X is C, and 152 is B, like in these orders. Then you just switch them around. So now we do log of 7 and log base 7 of 152, and you would just type that into the calculator. Now, this is something else you need to know. There's 2 ways that you can type this into the calculator. So, if you have a Desmos calculator, here's what you could do. You could do math. So first thing you do is math. You push the math button. Then you scroll down to where you see log base, and then when you click on that, it lets you do a base, and then you could type that in. If you don't want to do that, or you don't have a TI-84 or like a calculator like that, then instead you can just simply do this. Log of 152 divided by log of 7, because that's always what you can do. The thing that's in the parentheses divided by the thing that's not. So that's logarithms. That's what you need to know for that. Right? Next, we are going to talk about rates. So, and the rate that we're looking at is that distance equals speed times time. Now, I don't really like this because I took AP Physics 1, so I really think that it's better to do this. That's just like your common equation. But however you want to remember it, you just need to know that a distance, and that stands for velocity, which it's not the same thing as speed, but we're not taking physics, are we? So that doesn't really matter. You just need to know that. So let's say you're, and you can use this as an algebraic equation. So let's say someone goes, they go 15 meters in 2 hours. Well, you could plug in these values, and we're solving for t, and then so what do you know? Well, whatever the unit would be. Or what am I doing? Sorry. That's if we would actually be solving for s. Sorry, I don't know what I'm doing. 2 hours. So that's s, not a 5. So the speed could be meters per hour, or that's not really a common use thing. But anyways, that's something that you need to know. Sometimes that's a little bit easy for someone to remember anyways, because they think of miles per hour. Okay, now we're going to talk about functions. Well, what we're just going to talk about is something if you see a circle thing. So if you saw something that's like this, you might think fog. Well, that's not what that is. That's not it. Sorry, I almost knocked my iPad off the table. That's not a O. That's what that means is that you're actually doing this. You put the G and the F. If it was this, then it would be the F and the G. So you might think, I still don't get what that means. Well, here's what I'm talking about. If F equals 5 and G, if F of X equals 5 and G of X equals 7, then this one would be 5 times 7, and this one would be 7 times 5, so you might think, hey, that's the same thing. Well, just imagine if it was something like this, then it wouldn't be. So that's what that means. So that's the only thing we're going to talk about functions. Like, there's some things, we're just talking about basically like equations or formulas. I don't know if that's even really a formula, but alright, here's the next thing. This is not that common, but you need to know that pi radians equals 180 degrees. So these are two different units that could measure an angle. Radians and, well, that's not even really the right thing. It's really rad. Those are 2 units, so you just need to remember that. So you can convert. That's really like a conversion factor. Okay. So now we're going to talk about just basically algebra. So first thing we're going to talk about is slope formula. That is something that hopefully you remember, but it's simply just this. This b is the y-intercept, and this is the slope. Slope is rise over run, so it's the change in y divided by the change in x. So essentially, this divided by this. So whenever you have to change in something, it's the final thing minus the initial, or always basically the 2 minus the 1. So this is the slope formula that equals that basically. So if we're looking at a graph, let's say we had a point here that is 1, 3, and a point here that is -2, -2 or something. If we wanted to find the slope, then we would do y2, the second y, we could just call this x1, y1, and as you'll find out, it doesn't matter what thing you choose, because it still comes out the same. So the y2, that is -2, y1, 3, x2, -2, x1, 1. So if you solve that out, that would get you m, and if you saw the y-intercept here, then that would tell you that, and then you would know the equation for that line. So that's what you need to know. Those are two things: the slope formula and the slope formula and the slope intercept formula. Okay. Now there's something else that's called distance formula. So going back to those same points, what if you wanted to know the distance between them? That's not the same thing as slope. Instead, you need to do this dumb thing. You need to remember this thing. It is this. And once again, it doesn't matter actually if you did what order you did this in, because of commutative property. But you just have to have the x's and the y's together, but I would just recommend doing this one. So you would simply just plug in the numbers, and that's how you can find the distance between them. Now there's another thing that you can do that's even different than that. So that's just finding, oh, of course I deleted that. So that was the distance formula. That's just like finding this. How long is that? But there's another thing we can do. How do we find the midpoint? The midpoint formula is this. If you want to find the x coordinate, you do this. If you want to find the y coordinate, you do this. So that's simply what you do. It's not that hard, really. Okay. So that, yeah, those are very useful. They make things a lot quicker. That way you don't just have to guess. All right. Another thing that you would want to know is how to FOIL. So let's say we needed to multiply these things out. Well, FOIL, you might have learned the box method also, but FOIL is an acronym, and that is first, outer, inner, and last. So we're multiplying different things. So I'll just color coordinate this stuff here. So if we're starting out with first, the first things are these. X times x, that's x squared. All right, plus, now we're doing the outer. The outer are these things. X times 5, that is 5x. All right, plus, the inner, those are these things. So that's 7x. Positive 7x. So then plus the last things, those are 7 and 5, that is 35. Then you can combine the x's, and then we have this. That hopefully is something that you know how to do, but that's how you do it if you didn't know. Okay. All right, let's continue. The quadratic formula, once again, not use that much, really. The quadratic formula is -b plus or minus the square root of b squared minus 4ac divided by 2a. So if that doesn't make sense, what are a, b, and c? Well, that's just your standard algebraic thing, basically. usually if there's nothing here, then A is 1. If there's nothing here, then B is 1. So that's your standard algebraic thing, and you might have to rearrange it to get into this point, but it's always going to be something x squared if it's a quadratic, and then there's a 1 there, and then there's no x for that. So you simply plug that in, and then what about the plus or minus? That's because you get two solutions. So you solve it out one time by doing plus, and the next time when you type it in the calculator, you do minus, and then that gets you both your solutions. Specifically the part that's under the square root, not including the square root, that is called a discriminant, b squared minus 4ac. Once again, not the square root. But if that is, we'll just call this d, if it is greater than 0, then there's going to be two real solutions. So what does real mean? Well, that means it's not going to be like if it's that's not real. Okay, just a negative thing. If the discriminant equals 0, then there's only going to be one real solution. If it's less than 0, then there's going to be none. Because, like I said, you can't do this square root of a negative thing. So that's that. That's quadratics there. All right, so let's continue. There's still more things you need to know, unfortunately. Well, let's talk about sort of like statistics and probability. A percent of something is a part divided by a whole, and you have to multiply it by 100. That's kind of hopefully obvious. If there's 4 people wearing hats in a class of 19 people, you do that fraction times 100 to get to the percent of how many people have hats on. Right? If you're trying to find a percent of something, so what is 4% of 150? You do 150 times 0.04 because that's just converting the percent into a decimal, and you always just move it back 3. Oh, sorry, you move it back 2. Or you just divide it by 100, whatever thing you want to do. But that's what it's like. All right. Now there's the just common things. Mean, or the average of something. You basically add everything and you divide it by total number of whatever it happens to be. So if this test scores of 4 people were 71, 81, 91, and 100, to find the average test score, you add those together, you divide it by 4 because that's how many people that you're doing the average of. That's average or mean, same thing. There's other things too. Maybe you remember the other ones that are like that you learn. Median, that's the number in the middle. So if you have numbers like 5, 17, 4, 13, 9, how do you find it? Well, you have to put them in order first, and then you cross them out until you get to the middle. But there's sometimes something that you have to be aware of. If there's an even amount of numbers, so let's pretend that 9's not there. Now we just have 4, 5, 13, 17. So you cross that out and you're like, hey, what do you know? There's nothing there. Well, you have to figure out the average of that. So basically, you pretty much have to find the mean of those two things. And so you just do that. And that would be 9. Anyways, that's just a coincidence. Okay. So the median can be a decimal number, by the way. Mode, that's probably the easiest one. It's just the most common number. So if you have 9, 14, 15, 17, the mode is 14 because it's the most thing that there is. Then there's the last thing is the range. That is the high minus low. Low, high, high, low. If you know that Black Keys song, don't listen to the low, high part. Listen to the high, low. High minus low. So let's say we had numbers 4, 41, 3, I don't know, I'm just making up random things, 31. The range is this. That's the highest, that's the lowest. Alright, so now that was mostly just like statistics. Now we need to look at probability things. So probability. Well, the probability that something could happen is number divided by total. So let's say there are 3 red marbles, 3 blue, 2 red. What's the probability that a red could be picked? Well, what do you know? That's really just 2 out of 5. That's kind of simple. There's 5 total, 2 reds. But there's some things. Let's say that there's 2 different situations, A and B. So A is that it will rain, and B is there will be wind. First I was going to say won't be rain, but then I realized that wouldn't work. How do you find the probability that both things will happen? Well, you have to multiply them. So if the probability of this was like a 1/17th chance and this was like a 2/17th chance, then you multiply them. And if you notice, that would make the number smaller, which makes sense because it's a less chance that both things would happen. So that might be something that you just never learned. That was the case for me. But that's what that is. Okay. Now we're on to geometry. So we've been through a lot of things. All right, now it's geometry. All right, there are formal terms for these things, but I will say them, but that's not really what matters. So let's say you had an angle like this. And there's 2 angles, angle A, angle B. Well, angle A plus angle B are always going to be 180 degrees. That's what it's like. And those are called supplementary angles if you want to get technical, but you don't really need to know that for this. Now, there's another thing. If you have something like this, you know this is a right angle. So then you have A and B again. Well, A and B, they're going to have to equal 90. That is complementary angles. And you would know that this is 90 because I already said that supplementary equals 100. So, okay. Now there's another thing called vertical angles. That means that these blue ones would equal each other and these red ones would equal each other. Because they're across from each other. Those are really the only angle things you need to know. All right, more geometry things. It's always useful to know the Pythagorean theorem, a squared plus b squared equals c squared. Hopefully that's a simple one that we know. And once again, if you somehow don't know what that is, this is always c, the thing that's longest and across from the right angle. It could be ab, it could be ba. It doesn't really matter because, once again, commutative property. You can still do that in a different order, and it wouldn't matter. Okay. Now what? Let's talk about the angles in a triangle. No matter what it is, doesn't matter. Scaling, isosceles, right triangle, whatever, obtuse triangle, acute triangle, doesn't matter. The angles always add up to equal 180 degrees. So angle 1 plus angle 2 plus angle 3 equals 180 degrees. That can be very useful. And sometimes the angles and triangles are combined. Well, commonly they are, so yeah, you would want to know that. Now the area of a triangle, I'll just say that is 1/2 times the base times the height, or you could just say base times height divided by 2. That's what I commonly do. That's a little bit sometimes simpler. So if you had a triangle like this is the base, this is the height. So if you were trying to find the area of it, then you just plug in the things. Now we're going to talk about triangle ratios. This is not a very common thing, but you could see it. If you had a triangle that had 90 degrees, 45 degrees, and 45 degrees, that's a common triangle. Across from the 45-degree ones, you would say x, x, and this one would be x times square root of 2. Now, what does that mean? Well, that's just telling you the relationships between them. So that could help you solve for things if you had lengths of sides. There's also one other kind that you might want to know, which would be, I'm going to try to draw this the best I can. It's not to scale, but let's say this is 90, this is 30, this is 60. There can be ones like that. And when it's like this, across from the 30 is x, across from the 60 is x squared to 3, and across from the 90 is 2x. So that would be useful to know too. I would rewind the video and screenshot that if you don't know. Alright, bye-bye geometry. We don't need... That's all the geometry things you would need to know. Well, these things are still kind of geometry. Yeah, so sorry, that's still more. We're talking about a trapezoid. So a trapezoid, if you don't remember what that shape's like, it's just some kind of thing like this. It just kind of looks like Napoleon's hat. And if you need to find the area of that, you would do this. The bases added divided by 2 times the height. So what are the bases? This is the first base, this is the second base. The height is this. It's not this, it's that. So that's how you find the area of Napoleon's hat. Alright. Now, the perimeter, in case you don't remember what that's like, that's adding the sides. So let's say this is 3, this is 5, this is 2, 1, 2. So that would mean that this is 3. So you just add. That's perimeter. And the area of a square, or the area of any parallelogram, so it could look like this, it could look like this, it could look like this, it could look like anything like that. You just do that. Base times height. And the height, if it's something like that that's slanted, it's always that. Okay. Let's see, what else? Alright, now we're going to talk about circles. An arc length, this isn't very common, haven't really seen this that much. An arc length is the, let's see, how should I put this? Central angle, so theta can represent angle, divided by 360 times the circumference, which is 2 pi r. So that's just like two things in one. The circumference is 2 pi r. So that's an arc length. That's not that common really, but if you saw that, that's what you would do. Then there's not only circumference of a circle, there's also area of a circle, which is pi r squared. Sometimes people get these mixed up, so make sure not to do that. The diameter of a circle is always 2 times the radius. That's something good to know. So that means the radius is the diameter divided by 2. Okay. Now, whenever you have, this is what a circle equation can look like. Maybe you learned this in Algebra 2. The center of the circle is HK. And the radius is r, not r squared, so you would have to take the square root of this. So if this was 49, then the radius would be 7. So don't get mixed up with that. All right. Now, let's see, what do we have now? Going to 3D figures. The surface area of a rectangular prism that would be 2 times the length times width times, oh wait, oh sorry, law le wu. That's what I was remember. Law, LW, le, wu. Like all the combinations of those things. So the length could be this, the width could be this, or we'll just say it's this, and the height could be this. But once again, it doesn't matter really what order it's in. So law le wu. That's how I would remember it. 2 times law le wu. Plus, and you add those. Okay. All right. Trigonometry. Trigostupidry. Well, you need to remember SOHCAHTOA. So, what is that again? Well, if this is our angle, this is opposite. This is hypotenuse. This is adjacent. Hypotenuse is always that thing. And you can only use this with the right triangle. Never try to use that with something like that. And same thing with Pythagorean theorem. So if you were trying to find a sine of the angle, it would be the opposite times, or divided by the hypotenuse. Oh, I don't know, I skipped cosine. Try and do the cosine. That's a divided by h. Try and do tangent. That is o divided by a. So there you go. I'm starting to get tired of talking, so hopefully there's not that much things left. So let's see. I'm trying to search and see what else I have. Matrix things. That's not really a formula. But whenever you're multiplying 2 matrices, the middle thing has to be the same. So if you had NM times MK, you could do that because the middle thing is the same. But that's the other things are just kind of simple because you just do the corresponding things. Like if you were adding this or whatever you were doing, that it's kind of simple basically. Okay. There's law of sines and law of cosines. Law of sines. That is basically, let's say you had a triangle like this. This was 41 degrees. This was 67 degrees. This was x. This was 7. You're trying to find x. How could you find it? Well, it's kind of just like ratios almost. You have the sine of something, and the length and the length. So, and you have to do the things that are across from it. And that's how you could find x. That is the law of sines, not that commonly used, but you could see it. And then there's the law of cosines. Law of cosines, which is x squared equals a squared plus b squared times a times b times cosine of angle across from x. So if you had something like this, just a non-right triangle, you might want to use this, and A could be a side, B could be a side, and you could be trying to find this side length, and you know this angle, so it would have to be across from x. If it was this one, then you'd have to solve using the 180, how they all add up to equal 180 or whatever. So that's that, and some other things. Least common multiple, least common factor, greatest common factor. Okay. Or sorry, let's just say least common denominator. Okay, we're gonna just look at these things. So let's start with least common denominator. Let's say we have 3 fractions. Okay. We're trying to find the least common denominator. When we break apart the denominators, this in fact can be break apart into that, and it has to be all prime numbers, like it can't divide out anymore. This one would be this, 3 times 2 times 2, and this one would be this. You only multiply the same things, so multiply the same, but no repeats, and that gets us 6. So that's what that is. Now, the other two, hang on a second, I'm trying to pull up an example here. Hold on. Trying to find the stupid thing. Oh. Okay. Okay, so the least common multiple for this one, you need to multiply all except the same on it's kind of hard to say this. I had this problem before. Same for different numbers. So what does this mean? It's way easier shown than said. Let's say we had 30 and 40. Well, when we're breaking these apart, you still have to break them apart. So 30, that breaks apart into 2 times 3 times 5. 40 breaks apart into 2 times 2 times 2 times 5. Sorry. So we would need to multiply all except for the same for different numbers. What's the same for different numbers? These 5s and these 2s. Since we have more than one 2 on the bottom, we can multiply all these. So yes, yes, yes. Yes, but we're going to not do that because we already had a 2 right down here. And we're not going to do that because we already had a 5 down there. So it would end up being 2 times 2 times 2 times 3 times 5. Greatest common factor, let's just use the same example. for this one, you need to multiply just the same. Well, that's a little bit similar to the least common denominator. So if we're multiplying the same, these are the same, these are the same, but we don't need to duplicate it, so we just do 2 times 5, which is 10. So it's pretty simple. So those are those three things, and with that, I think now I've said everything that you would possibly need to know. But let me highlight the ones that I think are the most important that very commonly show up on almost every math test, because those were a lot of things. So if you want to know what to focus on the most, I would say definitely this one. Definitely this one. Definitely this one. It's the distance formula. Definitely this one. And if you don't know your percent, then I would know that it's part divided by whole. I would know your angle rules, the 180 degrees in a triangle. And I would know that the area of a circle is pi r squared, and the circumference of a circle is 2 pi r, not get those mixed up. And I would definitely know SOHCAHTOA. The other things I talked about aren't super common, but you should still try to remember them. But these are the most common things. That's it.